There. So one more time, welcome you all of you, and I hope that you hear me well, that my voice is strong. We'll see if it will be strong after 5 days. And in this lecture 0, I want to show you motivation, why we care about this problematics, and told you some details about courses. So why this course? This course we create due to long time cooperation with IIT Guwahati, because I closely cooperate with Dr. Gaurav Trivedi and partially with Dr. Aswini. I am from University of Pardubice. I will show you where it's located, and I am head of department of electronics and radio system in this university, in Faculty of Electrical Engineering in Informatics. University of Pardubice is relatively small university, but everything in Czech Republic is small with comparison to any Indian city, so it is it is normal. We are a small city located about 100 kilometers east from Prague, so it is about 50 minutes by train from capital city. And why in Pardubice is so important for radars, even for last 100 years? Reason is that in 1919 there was founded a company named Telegrafia, and from this period of times starts history of radio, electronics, electrotechnics, and all these techniques things. Pardubice is relatively small city, 100,000 people, but their work, I think, from 100,000 people, about 3, 4, 5, maybe up to 10,000 people works in industry with radio electronics. So during communism, the Pardubice was center of radars parts of Eastern Europe. So we developing radar, or not me of course, but there was developed radars for Eastern country like Ukraine, Russian, and all these countries, and it was developed in Pardubice. So there is really long history. I will show you later. So there is some link to our university, faculty, and departments. How professors say, it is about networking. So if you want to cooperate in anything, just let me know. Just you will see at the end of the lecture always my email, so you can send me email anytime, and we can make any arrangement. If you want any data, any information, just please let me know, because networking is on this way very important. Okay. Where is located of Pardubice? I just make one short video. We are in center of almost Czech Republic, so you can see location of Prague, there is location of Pardubice, and it is about 100,000 people, and we are located, our faculty is like directly in center of the city. So we are small faculty. Our history is only about 15 years old, but we have strong cooperation with industry, and a lot of professors are directly come from industry. So it is really good for us. It is really good to opportunity with working with industry. So our main partners are from industry, and it is related just to radar technology, how we will see later. So why this course? Why is this so important? Because you probably know what's radar doing: detecting targets, controlling airspace, or there is lot of different application. But it is one side of question. Second side is renewable green energy sources rapidly growing. How Professor mentioned, every 1 year in India is growing industry about 4 gigawatts per year. So it is mean that not grow only number of wind turbines but also their sizes. And it is start be problem, because imagine wind turbine is big object and blades, it is rotating object, and this rotating object has similar or same signature for a radar like flying target. So generally speaking, if you have some, like example, enemy plane that will be close to some wind turbine farm, you will completely lose detection. You don't know where is this plane, because you will see just wind turbines due to stronger reflections from wind turbines instead of reflection of this target. So it become very big problem, and especially where you can install wind turbines in area that are free, very strong wind, and where you install radar, where is free area because you won't see longer distance. So this mutual coexistence start be really crucial thing, because you need to follow how we can deal with this coexistence. Because of course we need green energy, but we need safety in airspace also, and both together it is not easy to do it. So it is just motivation why we doing this course. On this course I work with my colleague that I want to mention, Dr. Jurica, that made PhD thesis on this problematics. So a lot of picture that you will see with signature JK, it is from his thesis and it is his contribution or mutual contribution. So in one sentence, there is a huge impact on radar performance, not only in air traffic control but also of course in military air traffic control or air defense. So we need to mitigate this influence. And next 5 days we will talk about how we can, first, before mitigation of course, we need to analyze what is impact. How looks this impact? Because you can imagine that wind turbine is rotating, and this rotation gives you in any time with any position with respect to radars always another reflection. So it looks almost like random movement from point of the reflection. Of course, speed of rotation also change rotation, and so on and so on. So there is so multiple variables that is not easy to predict what will be behavior for mitigation techniques. So I will show you slowly how we continue. By the way, I have one question. Do you have some experience with radar signal processing? Do you know how works radars? On which principle? I just ask. If answer is no, never mind, because I will show you. I'm just asking if you have some experience. Okay, perfect. Thank you. So I am most worried about this part because my second lecture is about radar system and signal processing, and it is very, very long and will be very, very intensive for you. So please don't hesitate, ask me anytime, because you need to understand how works radar, because if you don't understand, then influence of wind turbines to radars will be hardly to understand, if you get my point, because you need to understand how it works. But don't worry, we will handle it. I hope that have a lot of picture and it will be, everything looks nice. So we choose a methodology how we'll deal with this, because of course people found it that there is some problem with reflection of wind turbines close to radar. So first we realized that we need to make observation of real wind turbines in classic environment and check it how looks like this reflection, how describe this phenomena of this reflection. Then we just think, okay, so we take one measurement, so it is mean that you need design a measuring chain, you will go outside, you will measure reflection of wind turbines by some radars, you need very expensive equipment for this, and so on. And now imagine, you will come to some place and there is no wind, so wind turbines stop. Okay, so you will come next day, and it costs you time, money, and of course you don't need only one management, you need thousand measurement for design of mitigation techniques, but it is not possible. They even don't allow you go too close to wind turbines because very often it is protected area. So we just think, okay, so we will try design some wind turbine model or simulator, you call it model or simulator. And in the last 3 years we designed this simulator, and we designed this simulator that you will place in our simulator radar with specific parameters, wind turbine, one or more, and output is reflected signals from these wind turbines. So we can set a lot of parameters that you will see later, and this could be same results or very similar results like from measurement. But you don't need to go outside, you just run software, set and watch a result. So it is much effective and it not cost you almost anything. Our simulator was designed in MATLAB because I think that in academy is very usual environment and it is easy to use. So of course we must be sure that our simulator is good, that produced output is same like from real turbines measurement. So we also measure some real reflection and make comparison, verification of model with real measurement, and I think that you will see later result that is not perfect of course, but very good similarity. So we can use it for designing for mitigation technique. Okay, our system for mitigation of wind turbine influence on primary radar system is based on extraction features, prediction features, and filtration. It is just 3 base step. You will see this later. And after this we make model validation, and now is used for any scenario. I will show you later results about 4 different scenarios in different place of Czech Republic and one from Austria, where we make comparison of our simulator with real measurement. So green energy spreading around the world last 30 years, and I think that is important part of our life. I think that you can also see it in your country that this topic is very modern, and number of, I will focus only on wind turbine, not solar plants and so on, because it is my topic of lecture. And wind turbines spreading everywhere, especially in area where is strong wind and like solid wings, not any, just only for few minutes, then nothing, and so on. So it is clear that it is good source of energy, and this massive expansion of wind turbines negatively impacts functionality of radar system. especially deterioration of their detection capabilities or target masking. On the right picture you can see some wind farm, offshore wind farm, that could mask you almost any flying object, because imagine that there is no synchronization of this wind turbine, so any wind turbines rotating with another speed, another blade position, and so on and so on. And if you will see reflection on radar of these wind turbines, it will be like one big target. You don't see anything, just anything, and it is very dangerous, especially on coast. If you will have some enemy, something always come from coast, so you need to see. But we will stay in civil, even for air traffic, of course, because density of flights is also increasing. The like limits between two aircraft is still minimizing, so they are close to each other, so you need to be really sure where is your location of your target. So this course, this will be just few brief slides. This course will take 5 days. Lecture part is about 14 hours, 1 hour 60 minutes. Tutorial part will be about 8 hours. Of course, some lecture could be shorter, some longer, because I try to adopt it, but it is first time, so be please patient with me a little. Today will be, after this lecture 0, how I call it, will be lecture 1, where I focus on renewable energy in India. I just prepared about 7-10 slides just for you, because you will see where is windy region, what is number of wind turbines, and so on and so on, so it is adopted for your country. Then I will briefly describe general radar system description, their application, purpose, and classification of radar system, because I will focus only to primary radar system, but there is lot of different type of radar system. And few words I will say about the history of development of the radar. Second, or lecture 2, it will be during this afternoon. It is, I think, the most demanding probably for you, and it will be about signal processing in a radar system. And there is lot of blocks with specific purpose that you need to understand. So please, anytime, just stop me, even during my talk. There is not any issue, just stop me and ask me if you have. And I hope that will know all answer, and if I know answer, I will quickly answer you. So we will finish first day on first part of tutorial 1, and it will be completely in MATLAB. So if you can bring after lunch your laptop, just bring laptop, and I will share link with MATLAB, and we will work together. It is much better. Second day will be about description of wind turbines, because okay, I'm talking about wind turbines, but wind turbines is divided to many parts, and each part have different influence to radar, so we will need this description. We will talk about principle of operation, usage onshore, offshore. We will talk about radar cross-section of tower blades from different direction, about spectrum. By the way, I suppose that a lot of you is from electrical engineering, so I suppose that almost all of you know Fourier series, Fourier transform, you know what is spectrum. It is perfect, it is enough, we don't need anything else. Okay, we need to know what is spectrogram, but it is same, just changing spectrum in time, so it is enough. But don't worry, we will not compute it anything, it is just I need these terms. And then I will discuss also mitigation approaches of wind turbine and state of the art, because a lot of companies is interesting about these topics. So I found about 8 up to 9 companies, and I will show them these products for mitigation of this influence. Then we continue with lecture 4, and it will be about design of simulator. So we will make description of geometry of wind turbines and radar system, or wind farms, simulation of received signals, deep analysis of wind turbines influence. But it will be all, like to say, in theory, about mathematical description of this model. There will be a lot of formulas, but don't worry, I will explain you by words, so it is not important to, how to say, remember all this formula, because I don't know how you, but I don't like any memorization of formulas, because it's necessary. You need to understand principle. Formula you always can find it in some book, so it is not so important. Then we continue with tutorial 1. It will be again related to some radar equation, power budget in radar, radar resolution, matched, unmatched filtering, and so on. Day 3 will be about modeling, development of simulator, design, testing, validation, block scheme simulator, and mathematical description. Then we will continue with tutorial 2. That will be on usage of simulator. Again, all MATLAB, so please laptop with you tomorrow. Every day, generally every day. Day 4 will be lecture 6 and tutorial 3. It will be challenges with wind turbine measurement in the field. I will show you that it's not easy. Of course, you need to have some radar. Radar is expensive things for $1 million, and it is not so easy say, okay, just take radar and when we go to measurement. It is not possible. So we design a measurement chain based on software defined radios. It is small boxes only, and I will show you how set up, how prepare all this measurement chain, and then what you need for this measurement chain. Of course, it is also you need some equipment, but it definitely is not so expensive like the wall radar. And on tutorial 3 we will make simulation of real case scenarios. So I have prepared tutorials where I show you where is wind turbines, and through some GIS software like maps.com or Maps Google or something like this, how design, where I should put my measurement, how I can be close to wind turbines to proper results of measurement, and so on and so on. It is not easy task. Also, you need to be worried about permission, because you can't go to any place and just start transmitting some energy, because I think that it will be really big fine in any country in the world. So I will describe you a few words about this one. And day 5 will be held to mitigation of wind turbine influence by pure software solution. I will show you that exists many hardware solutions. Again, they are definitely more expensive, or you need to make modification on present radars, and it is also very expensive, long time goal. So we develop with colleagues mitigation technique that is purely software, and it is relatively easy to implement because you don't need change any hardware in radar. It is just in software. So I will show you, and it will be lecture 7. And tutorial 4 will be it will be presentation of complete mitigation algorithm of our, again developing in MATLAB. I will share all scripts, all applications, so you can, even after finishing course, you can play with this without any problem. And we will end with lecture 8, but it will be just conclusion, discussion, if you like it, if you don't like it, where I should improve, and so on and so on. So it will be more about your opinion. So totally we will spend together for 14 hours with lecture, 8 hours with tutorials. So I hope that you will enjoy it. And the end of each lecture you can see my contact information, so you can contact me anytime on email, just anytime, it is no problem. Okay, so it was lecture 0, and I will continue with lecture 1, or now, yes, lecture 1 now, yeah. Because honestly I don't remember what it yeah, but we have now lecture 1, so it is good. So what we need, okay, what is wind turbines for us? Wind turbines are not only obstacles but dynamic scatters that can create detection losses, masking and fault tracks. So we need first to understand of this impact phenomena, and this impact phenomena is divided to many parts, how you can saw it later. So first we need to make analysis of the radar signal or data, because later you will see that we are not working only with signals that we receiving by radar antenna, but very soon after some pre-processing we just convert it to data, because of course 0101 it is better for processing for us this data, for storage, for anything that analog signal. So it will be first step. Then for us is important modeling this phenomena, because how I already explained you can't go anytime to specific position, you don't know if will be wind turbine rotating or not, and so on. So we need to model this phenomena, but not only for one scenario, but for any combination of any input parameters, because then even, and it is our plan to future, you can if we will collect a lot of data, make a lot of simulation, we can gather all these outputs and try use some machine learning techniques for some mitigation based on like automatic adoption of this mitigation. So it is really important how to say easily, without measurement, without data, you can't do anything. So it is main importance why we designed this simulator. So design of second after analysis, of course, is designing of mitigation techniques, and these mitigation techniques could be based on special hardware, on signal processing method design, but always all possibilities that you choose must be adaptive, because imagine you will make some mitigation algorithm that works perfectly for your settings. Now wind will be quicker, it will be quicker rotation, and your mitigation just fail because it is not adopted. And this adoption is really big problem, because there is so many influences that it looks almost like a random behavior. But I think that we was successful, that we split to some important part. So solving all these problems restore the radar wind turbines free performance, and we again can see even in geographical areas where is presence of wind turbines. So first, something about global wind energy contents. There I want to show you that due to high spreading of installed wind power capacity, so it is mean a number of wind turbines, influence on radar will be increasing and increasing. So I think that is relatively important topic, because even now we make study before 3 years when one company have installed small wind turbines close to weather radar, and we have in Czech Republic, we are small, only 2 weather radars because it is covered the whole Czech Republic, and it was about, if I remember well, 5 kilometers far away. And it was old wind turbine, small one, I don't know, 25 meters, 30 meters, nothing big one. And they want to install some about 90 meters tower with blades about 40 meters, if I remember well. And now people from radar station, weather radar station, discover, oh, you can't get permission to making one because it will influence of this weather radar. And it was true, influence. Not so big influence in this case due to mutual position, but still there was influence. So, and this like problematic places will be increasing, of course, because if number of wind turbines increase, there will be also increasing number of like conflicts between this. And there I want to just say that what is biggest player in global market. You can see that China is biggest player because they have in some area where it's really windy, so it is easy for them. Second is USA, third is Germany, and fourth is India. So I just want to present you that you are in top 5 of installed wind turbine energy. Later I will show you where, because I already made the discoveries, because I think that in Assam there is almost not any wind turbine installed, not many of them, because there is not area with stable wind direction, something like this. But I think that almost is in south, how we will see later. So I think that in India, for India will be big problem in close future also. On this slides I want to show you trend of onshore and offshore turbine size. You can see that development of offshore starts in 1990, something like this. Before this it was some maybe experimental, but definitely not commercial. Size of wind turbines was 35 meters with blade, if tip of blades it is about 50 meters, and power about half megawatt, relatively small one. Then 95, 2000, 2005 we have already 3 megawatts, about size 125 meters, then slowly growing up to 2020. It is about almost 200 meters and almost 10 megawatts, and in 2023 it is almost 300 meters and 18 megawatts. And now check this red area. Uncontrolled space limit is 300 meters or 1000 feet. So it is mean there is uncontrolled space, so you can do it, not almost anything, but a lot of things. But everything under 300 meters or 1000 feet, it is controlled space by air traffic control. So the highest wind turbines is on the edge of controlling space. And if it will be growing, still growing, then we have really big problem. So it is not only academic question I want to just discover, and it is about offshore. And look on onshore, it is below. Onshore, it is oh, sorry, I just misunderstand. Onshore is of course a little slower, but offshore is bigger, because there is not so big problem on the sea, close to sea. Okay, about some renewable energy in the Republic of India. This will be only about wind turbines. I don't discover any other green energy sources, because I suppose that I saw also a lot of solar energies and so on and so, but probably you know about this much more than me. So India wind sector really rapidly growth at last 20-30 years. From history of development is early begins in 1980s, 90s, so you can see it is same like in the rest of world. Of course, you will follow your modern society, so it is global. It is global. So first modern wind turbines were installed in Gujarat, Kutch region. Sorry for my pronunciation, because I don't know what is good pronunciation. In late 80s, and it was first commercial energy project. In 87, India was founded Indian Renewable Energy Development Agency, I call it IREDA, which financing a promotion of wind projects. From 2000, it is institutional support. It was formulation of National Wind Solar Mission in 2003. Stimulated domestic manufacturing and installation of wind turbines. So this means that you don't want, of course, buy all technology abroad because it is expensive, but you are start developing own wind turbines, own technology, everything by own. So it is always better for country than buy only things. There was also in each state, it was like state agencies and policy frameworks facilitated the development of wind farms. Three big regions where is a lot of wind turbines, how we will see later, is Tamil Nadu, Maharashtra and Gujarat. From 2009, in 2009, it is very interesting, you have installed only 2 gigawatts in the whole country, and in 2019, only 10 years, 31 gigawatts. So it was also like driven by Ministry of New and Renewable Energy, by favorable policies, international investment, technological advancement, and focus on reducing reliance on fossil fuels. So this, like how to say, government support means that this industry still will growing up. And India is big country, so it is mean a lot of airports and lot of wind turbines in the same. It is not good connection, how we will see. In recent developments after 2020, it was set a national plan, and target is in 2030 that your country should have installed 60 gigawatts in 2030. I think personally it is set by National Renewable Energy Action Plan, and honestly I think that it will be quicker, because your energy industry growing every year about 4 gigawatts, and I think that you will fulfill this plan about 2027. So there is really big primary focus on this. There I found windy regions map, so you can see that on this area, I think that is Rajasthan, if I remember well, and in this area it is the biggest wind that is suitable for installation of wind turbines. So I don't know, do you have, please can I ask, do you have experience, do you see a lot of wind turbines in this south? Because I never visit south, I always travel in the north. So can you confirm me? Yes? Yep. Mm-hmm.
Because of the seas?
Yeah, I think it. And also there is some mountains, I think, so mountains with combination close to sea, there will be windy region. Yes, 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 I think it, because of course I check map but never not see in my own eye. So, and for this reason I think that in Assam around this there is not so windy, and it is also close to this highest mountain, of course, Himalaya, and I think that is unpredictable wind. So there maybe is reason, I don't know, of course. So I think that the majority will be installed in this area and maybe in Rajasthan in this area. No, I don't know, it is not me. Maybe. No. Yeah, yeah. But it is might be C. But it is go from this PC. It is not my PC. Never mind. I think that they will shut down soon. So there I found it some by the way, I don't told you, each source in my lectures is with citation, so if you want check sources of all these links, you can easily do it later. I also will share this PowerPoints, I will prepare PDF, so you can check it later if you are interested. So this is pictures from Gujarat, Tamil Nadu and Karnataka. There, okay, and now I've switched down internet, so I will connect it. Just give me seconds. Okay, check. Just for quick explanation, I don't use it maps.google.com, but this mappy.com, it is Czech version, and there is one good functionality. You can saw it line of sight between two places, you can measure distance, and it will show you digital elevation model. But Google don't have this functionality, so we use this one. It is very handy. Of course, I have it now in Czech, but you can easily switch to English, so don't worry, but it is good tool. Of course, if you like Google Maps, you can, but there is not this functionality. And Czech, I am now in south. And if I will make just zoom, look, all this is wind turbines. Check how many wind turbines is in this region. I was very impressed about this because it is everywhere. And imagine, oh, you don't saw it. Sorry, you should tell me. Okay, I need quick presentation and show him up. Sorry. Okay, so one more again. I am this region. It is Tamil Nadu. Yes, thank you. And if I will zoom it, check. I was really impressive. It is wind turbines is just everywhere. And check about resolution. This is 800 meters, so okay, it is about 1.2 miles. So it is almost everywhere, density of this wind turbine. Probably it will be some small. Honestly, I can't find any information which type, which developer, but it is just everywhere. I don't know. Do you visit this place? Somebody from you? So it is just everywhere. It is almost thousand of them. So it is exactly fit with map of wind region. Okay, now few words about radar. What is radar? I know that exists maybe 1000 definition what is radar, so I just take one from Britannica because it is very well known encyclopedia, and I don't want to use my words because encyclopedia is encyclopedia. So radar is shortcut of radio detection and ranging. Detect and tell me where is it. Of course it is just very brief, because in present times you don't know only information about where is target, but what is speed of target, what is which type of target, classification, and so on and so on and so on. So of course this is just from all the definition. By the way, when do you think it was developed first type of radars? What do you think? Just some guessing.
1940.
Exactly. During Second World War. Exactly. I have one picture exactly, because I think it started. I don't know honestly if Germany or England, but it was some mutual combination, of course, because one attacked, second made defense, so it was during Second War. Exactly. So this radar is device used for detection, tracking objects at long distances by transmitting high frequency radio signals and receiving the reflected signals. So it is definition from Encyclopedia Britannica. Radar system it's so many kind of different radar systems for short distance, long distance, automotive industry, military, and so on and so on. So tell you where we can use it. Answer is almost everywhere. It is just you need to adopt your radar system for purpose that you need. Exactly. Even if you go, I will make a little fun now, if you will go to bathroom, then is some sensor for turn on water. It is also some kind of radar system. But it is just joke. Okay. Radar system, there is some base block scheme. Please, this is very introduction block scheme of radars. Imagine that in each block it is 100 of small blocks interconnected together, but definitely it is generally starts with transmitter, because you need something what transmits electromagnetic wave to space and get reflection. So it is transmitter. Transmitter include designing of this wave, because it exists, maybe I know about 30-40 different kind of waves for transmission. And again, why so many? Each has different properties for different type of targets, and so on and so on. So transmitter, then go to antenna. This is device, call it duplexer. It is switching between transmitting and receiving, because when you transmitting power, it is really big one, because you need the long distance. And if you are receiving, it is, I will not call it small, it is almost zero, because imagine that a power decreasing with r, where r is distance, r squared. So r squared one way, r squared second way. So it is really small value. And for this reason, after you stop transmitting and waiting for reflection, you need to switch this duplexer. So this is disconnected, because it will destroy your receiver. During transmitting, if this power goes to receiver, it will be completely destroyed. You will just see fire probably. So after transmitting, you will receiving part, then there you made AD conversion. So there is analog, there is still some mixer, there is some analog devices, analog part, but after this we work only with IQ, so with complex envelope of some baseband signal. There is signal processor, and there is a lot of things you will see later on lecture 2. Data processor, and there is also local oscillator that makes synchronization between transmission and receiving time, and synchronizator, and display, and display is for visualization of results, and there could be 4 different type of visualization. And after visualization, this from process data, it could include tracking algorithms and so on. This could be communication outside, because you can have it network of radars, and this go to fusion center, and this fusion from different radar is fusion of data. Okay, thank you very much. Then there is some another things. It is like power supplies. This is like controlling mechanism when if radar works properly, if is there not any issue, and of course antenna gear, because we couldn't have it radar with static antenna, just watching to one side, or rotating antenna. So it is depends. So it is base block of radar system, and details you will see in lecture 2. So what is main purpose of radar system? First, navigation and safety for us probably is most important. So it is assisting aircraft, ships, vehicles navigate safely, detection obstacles, other vehicles, and geographic future. By the way, before 2 weeks I just talked with one friend that working in automotive industry. I am just asking, how many sensor radar, like different type of radar or radio sensors is in modern car? What do you think? How many of them?
Hundreds.
He told me about 70, so you are really close. 70, 100, it is depends. So yes, a lot of different sensors. If we talk about radars, I think that each car, if you has about, and unit view 360 degree, it is about 6 or 7 of radars around the cars. So it was really close. Then it is navigation and safety. I think everybody knows, because it is part of our life, so we know it. Then is military and defense. It is for detection and tracking aircraft, missiles, ships, potential threats. It is same principle, of course, but these military radars will have much better improvement, resolution, EMC protection, and of course some protection about listening, some coding, and so on and so on. But in principle, it is similar type of radars. Then we have weather monitoring radars. These radars works totally in different frequencies. Why? Because we need to see through clouds also. So it is lower frequencies, how you will see later, and it is for detection of storms, clouds, and any atmospheric influence, of course. Then we have air traffic control. It is managing and monitoring civilian and military airspace. And why I split air traffic control and navigation and safety? Because navigation and safety is usually primary radars. So primary radars don't require cooperation between radar and target. It is just send wave, get reflection, and get information from reflection. But air traffic control, usually, maybe you know ADSB, it is device that is placed in aircraft, and radar on ground send information, where are you, and this device answer, I am here, and send information. So do you see this difference? There is two cooperation sides. So for this reason I divided two groups. And then we have remote sensing, and it is Earth observation, geographical surveys, environmental monitoring, and so on. Google Maps, Google Earth. It is radar also. We call it SAR radar, SAR, synthetic aperture radars, and it is for monitoring ground, but it is also radar. Okay, when we can see radar application in real life? Okay, navigation, I already mentioned it. It is surveillance radar, precision approach radar. This is another special type of radar where it's used only on airports. If airplane is ready to land it, there is one special radar that told me with high resolution where is it, and if you are in good line for landing. So it is just about landing and starting, not just about landing. Then we have marine, coastal, shipboard. Of course we have radars also for underwater work, sonar, and so on and so. So you can see the application of radar is many of them. On military we have like battlefield radar, surveillance, weapon mounted radars. Then we now is become popular radars for detection of small, slow flying object, UAV, drones, and it is a really big problem. But you can probably imagine why. How you want to see drone at the distance 5, 10, up to 20 kilometers. Drone, it is this size. And imagine that you have like your radar, there is some wood, some big tree, and I am enemy and flying with drone. And there is wind, and tree do it this one. How you can recognize from drone this movement? It is really hard. And this very short range radar, it is now become very popular, but you can also saw it if you see conflict between Ukraine and Russian, because it is just full of drones. It is like war of drones looks like almost. So then we have automotive radars. So, and there I have a list of few examples: adaptive cruise control, forward collision warning system, blind spot detection, parking assistance system, automatic emergency braking, pedestrian and cyclist detection. All this one term, one specific sensor, one specific radar. Then we have police radar for the speed measurement. Okay, we don't like this kind of radars, but it is also important. And then I don't know if you heard about true wall radar. Don't heard? It is this one. It is from company Retia. It is also from Pardubice. Honestly, I don't know any other product, and it is used for police or anti-terroristic unit, because you just take it like this, place to wall, and you will see if somebody is on other side. But there is big but: if you have wall with full of iron bar, of course will not work. So it is working only somewhere, because of course it is like shielding. So but I saw it in action, and if you have, like, typically in US every building is relatively thin, if you understand me, from wood, so it is perfect. They use it, I know it, because the company confirmed me, they use it for detection of immigrants or something like this behind the wall, and so like this. So it is very interesting radar, and it is based on UAB signal. It is ultra wideband signals, because you need really huge bandwidth for detection of person through wall. Okay, there is a base classification of radar systems. We could divide it active radars and passive radars. Active radars transmitting energy and receiving echoes, and it is active because he needs to send energy and of course receive echoes. It is typically its primary radar system. It is this air traffic control, weather radar, and so on, how I already show you. Then we have secondary radar system for air traffic control, and it is this type radar that require small devices, so-called responder on airplane. So radar sent information, where are you? And he answered me, I am here. Where are you? I am here, and so on. And this communication is in every few seconds, in a very short period of time. So air traffic management, air traffic control always know where is target. And when I just imagine some big airport like Delhi, Mumbai, and so on, where is, I don't know how many targets around, but a lot of them, you need really good view where you have individual location of planes. Then is special kind of radars, and we call it passive radars. Do you know passive radars? Passive radars is radars that use transmitter of opportunity. It could be, it is usually bistatic. And what is mean bistatic? You know that monostatic radar has transmitting and receiving part in the same place. It is same picture that I show you sooner, this block scheme. So I have just one antenna. This antenna is used for transmitting and receiving. It is one antenna. But bistatic radars use separate antenna, and this separation could be few hundred meters, 1 kilometer, or 20-40 kilometers. And how it works? Generally, your radar is just receiver but not transmitter. And you can say, okay, if I didn't transmit anything, how I can detect targets? From which? From so-called transmitters of opportunity, and this could be like example TV transmitters, radio transmitters, because they are everywhere, because or GSM transmitters, but it is not so often because GSM transmitter, they don't have really long distance because it is a lot of them, but usually distance is few kilometers maximum. So usually it is DVB-T, on previous time it is analog TV or FM transmitters from radio, because there is huge coverage, generally almost whole country, and you just place receiver and listening, because if some fly, how to do it, if it's this receiver and there is some transmitters of opportunity like television receivers for DVB-T signals, and your targets fly around these transmitters, these signals from transmitters is reflected from target, signal is reflected to target and go to your receiver, and also direct signal, and from combination of direct signals and reflected signal you can compute where is target. What is big advantages of these radars? What do you think?
Radar seeking missiles, because there are missiles that seek where from the signal is emitted and they can destroy it.
Exactly, exactly. You are not transmitting, nobody knows where are you. So I think that there is clear what is main purpose, military. And passive system is not so very often used, and I must say that I am little brave that in Pardubice we have one company that developing these passive systems, and is called it ERA. I will show you later. Then we have multistatic radars. It is the highest level of type of radars. Imagine you have multiple radars in a network and they fused information together, and you have the coverage of the whole big area. And it is this one. Okay, now this few slide about history of radio technology in Pardubice. How I already say before, more than 100 years was founded Telegrafia company that developing classic radio systems, old stuff. There I found some old analog radio system. It was AM, you can see. By the way, we have one museum in Pardubice. One guy is really fan of these old things, and all this radio is functional. It is more than 100 years and it really works. You really can so it is amazing. Of course this not looks like that working, it is probably not this one, but he make reparation and works. This this company was in 1945 renamed to Tesla Pardubice, because after end of the war, it's in Czech Republic it was start of communism regime due to influence of Russia, and lot of company that was private is now state, so it was renamed just for why it was renamed. In 1950, what is very important date for Pardubice, was founded Radiolocation Research Center Opočínek. It is about 2 kilometers or 5 kilometers far away from Pardubice, and there was only one main purpose of this research center: developing of radars. Really focus only on radars. And it was of course part of this big Tesla company, but it was relatively independent part. It was just research center. So imagine in our small city, 100,000 people from 1950s, there is just focus to radars. and chemistry. Okay, if there will be my chemistry colleagues, they will don't agree with me, but from 50s also in chemistry. So chemistry and radio. There is some example of their products. So first products, it was radars PR1, and it is Czech name Kopáč. In 1970s was developed Ramona. In NATO, I think they call it softball. I think that you know why I call it softball. And this range in 1970, it was about 450 kilometers of these radars, and it was completely passive. It was passive, just passive. And later, next generation after Ramona was Tamara. It is in 1980s, and they call it trash bin. I think that you can also recognize why. And one funny thing, Ramona and Tamara, it is women's name, and I heard stories that of course in this company 90% of people was men, because it is techniques, and only some few females working on this, like some in technician position or secretary and so on, and it is name of these women. I don't know if it's true, but here that is true. It is just funny things. And later, it is in 90s, so it is after we get independence in 1989, and it is new version of Vera. So again, Ramona, Tamara, Vera, again women name, and it is third generation of passive radar system. I will show you last version of Vera NG later. So in Pardubice is many of radars company. I just want to show you example of the biggest one with biggest influence. It is Retia, Eldis and ERA. ERA focusing, and all this company, almost all this company is like divided from Tesla company, if you understand me. The big Tesla company was like separate to some small companies, and it is this one. So Retia company is specialization is in advanced air defense system, including command and control system, radar integration and short range air defense solution. It is focusing more on military solution, if I can say, but not only on developing radar, but a lot of other things also. But of course, I just present you what is important for us. Then second is Eldis Pardubice. It is significant player in air traffic control and radar technology. By the way, I will show you later that Eldis now control through their radar system more than 95% of Indian airspace. So if you are traveling in India airspace, it is controlled by radar from our small city Pardubice, from Eldis company. Last is ERA. It is specialization is in passive surveillance and multilateration systems. It is again a lot of military, and but also they develop SQUID system, and it is identification for system on airports, because you know on airport there is not only planes, but there is a lot of cars for pickupping, I don't know, baggage and so on and so on. And each this car has like small antenna, so you know where you can go, where it's not dangerous and so on and so. So they don't develop only military, but also for airports. Okay, some few details about Retia. They developing presently they offering 3 type of radars or 4 types, maybe more, but of course sometimes can be not publicly available. And I know that they develop now new generation also. So there is example of their products. It is Regard. It is 3D radar. It is family of radars based on AESA. AESA is antenna active phase array. So it is mean it is not classic antenna. It is active phase array antenna, and this is the whole radar. I think its weight is about 60-70 kilos, so 2 men can easily just drop it and use it. It is detection, it is short range radars about 30 kilometers, if I am not wrong, 30-40 kilometers, and it is suitable for detection also for drones. I think that they developed before 5 years, something like this. It is a relatively new product. Older product is Revisor. It is 2D short range radar for air defense. Again, this is radar that is rotating, and this could be static or also rotating. It is depends on how you want to use. And there is my already mentioned this Retvis detection person behind a solid obstacle, so you can see this one. This is about first generation has about 12 kilograms, and this next generation it is about 2 or 3 kilograms only. It is relatively light, and it is of course works only on battery for about 5 or 6 hours. But don't expect that you will see on your screen like the whole person, because detection is principle of detection is on detection of your heart. So you will see only red dot or something like this. We are not in movies. Second company is ERA. It is specialization, research, development, manufacturing of radar system for military and civilian application. And there is newest generation of Vera NG trash bin. If you remember from last slide, this not looks like trash bin, this one, but it is last generation, and it is completely passive system. Also, I already mentioned Squid ATS safety system. You can see it is placed on the roof of car. And then there is PLES system. PLES system is like how to say, long range radar system that like warn you like 500 kilometers I found can detect targets. So it is really big antenna, massive antenna, and it is developed with some military institute in Czech Republic. Sorry?
Using like S400 radar.
Yeah. So it is this one, but this and this, it is just pure military. And the last one is Eldis company, and there I just want to show you where it's placed. I think this company use on radar system for air traffic control only and surveillance. So they didn't, I think, develop so many military system. It is primary surveillance radar. It is this one, but please, I show you this one that is military radar. This is just antenna. Of course, radar is in this box, if I can say, but we call it, of course, that is radar, but it's just antenna of radar. So it is this primary radar system. This is this secondary radar system, so that require this device on the board. and this is this precision landing system, precision approach system, how I told you. So you can see all three together, and you have covered the whole airport with everything. So, and I found and discuss with them, because our faculty cooperate very intensively with LDs. We have mutual research project. Also we cooperate with ERA and RETIE. So we very often visiting, or our students visiting, this all three companies. Until now, it's 14 radar system installed at 2 major airports in India. So covering, okay, not 95%, sorry, 90% of airspace, but there is some future plan that about 2026 up to 2030, another 20 additional airport radars, and then will coverage by radars from Pardubice 99% of your airspace. So a lot of people from LDs, of course, travel to India, because you need to install, you need to maintenance, and so on and so on. And when I coming to Guwahati, and after just we landed, I just watching from window, and wow, it is in Guwahati. I am pretty sure, because of course my camera is not so good, so I can't zoom it very well. But if you can saw it, secondary, primary, I think that is in Guwahati is also radar from LDs. I'm not 100% sure, but 90% I am sure. After I come back to Czech Republic, I will ask in LDs company if it's their installation. There is zoom, but I am sorry, of course, it is just from camera through window. So, what is out now? So it is end of first presentation, and I am not sure if we have time. I need to check. Almost, if you agree, we can stop there, and now will be 1 hour break for lunch. So please enjoy lunch, and after 1 hour we will continue with second lecture. Okay, thank you for your attention. And if, of course, if you have now any question, just let me know. Discussion, remember, discussion. Okay, thank you. So enjoy lunch.